again. Gateway number 2. Going through each problem one by one. Hopefully this helps you out. Number 1. So a couple things messed people up here. I think some people thought it was chain rule. And some people got messed up because it was a fraction. But this is just like if I had, like y equals 4x squared. You bring down the 2, multiply it by 4. That's 8. Reduce the power by 1. So you're doing the same thing. You bring down the 2, multiply it by 3/4. So that is 2 over 1 times 3 over 4, which is 6 over 4. And it is negative. Reduce the power by 1. If you wanted to reduce that to negative 3 over 2 times x, you could, but you don't have to do that part. Number 2 is quotient rule. So we got the bottom times the derivative of the top, so 3x squared minus 2x minus big brackets, and then the top times the derivative of the bottom, which is going to be 12x to the third. That is all over the bottom square. And then I'm just going to leave the bottom square, and I don't have to do anything with that, but I do need to clean up the top. So this is not a simple one. I'm going to FOIL here, so it'll be 9x to the 6th. Outside will give me 6x to the 5th. Inside is negative 9x squared, and last is positive 6x. And then minus, and I'm still inside this big bracket. If I distribute here, 12x to the 6th minus 12x to the 5th. That's still all over the top of the bottom squared. And then I'm going to combine like terms here. So 9x to the 6th minus 12x to the 6th is negative 3x to the 6th. Negative 6x to the 5th minus negative 12x to the 5th is positive 6x to the 5th. And then the negative 9x squared and the positive 6x don't have any like terms, so they're just hanging out. And that will be your answer. Alright, third one is a regular chain rule problem. So I'm bringing down the 1/2. I'm leaving the little guy alone. I'm reducing the power by 1, and I'm multiplying by the derivative of the inside. And then you can't have a negative exponent, so we're going to clean this up and write it as a fraction. So the 1/2 kind of splits it for me. I'm going to put that 3 on the top, and then the 3x minus 1 goes to the bottom, and now has a positive exponent. Right. Number 4, part 1, is product rule. So h prime would be the second thing times the derivative of the first thing plus the first thing times the derivative of the second thing. And then we got to plug in 3. So I'm looking at 3 in the chart for all of these. So g of 3 is 1 times f prime of 3 is 1 plus f prime of 3 is 1/2 plus f of 3 is 1 times g prime is 0. So this turns out to be, I am plugging in the wrong number. My bad. Let's try that one again. So we're plugging in 1 here. I was looking at the wrong thing. So we're plugging in 1. My fault. So g of x, g of 1 is 3 times f prime of x is negative 1 plus f of x is 4 times g prime is negative 1, and that comes out to negative 7. Number 2 is quotient rule. So that is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So if I start looking at the chart now, I'm plugging in 3. So g of 3 is 1 times f prime of 3 is negative 1/2 minus f of 3 is 1, g prime is 0, over g was 1. So this becomes negative 1/2 over 1 squared, which is just negative 1/2. Third one is chain rule. So the big guy is that 2. Bring it down. Leave the little guy alone. Reduce the power by 1. Multiply by the derivative of the inside. And then we're plugging in 2. So 2 times, so f of 2 is 3. And f prime of 2 is negative 3 halves. So that if I think about multiplying, like 2 times 3 times 3 on the top is negative 18. 1 times 1 times 2 on the bottom is 2, so that would be negative 9. And then part 4 is also chain rule, where the big guy is the f. So you take the derivative of the big guy, you leave the little guy alone, and you multiply by the derivative of the little guy. And then we're plugging in 1 for x. So notice there's no x here. We're going to put 1 in those 2 spots. So f prime of g of 1 times g prime of 1. Well, g of 1 is 3. So now I want f prime of 3 times g prime of 1. So you end up with these different numbers here. So f prime of 3 is negative 1 half. And g prime of 1 is negative 1. So when you multiply those two together, you get a half. Number 5. Let's say 5, 6, and 7 were the 3 most frequently missed. First of all, I'm going to rewrite it. So it's 3x squared plus 5 to the first, and then negative 4x to the fifth minus 1. That'd be to the negative 1/5. So, second thing, so we're in product rule. Second thing, times the derivative of the first thing, which is just negative 6x, plus the first thing, times the derivative of the second thing, and now I need chain rule, so negative 1/5. Leave the little guy, reduce the power by 1, multiply by the derivative of the inside. Alright, so now I've got these 2 terms. I cannot have negative exponents, so I'm going to start flipping stuff down to the bottom. So this will be negative 6x on top, and negative 4x to the fifth minus 1 to the 1/5 on the bottom. Plus, now if I multiply negative 1/5 times negative 20x to the fourth, that is just going to be 4x to the fourth. Positive exponent, so we're on top. This has a positive exponent, so it goes on top, and then this has a negative exponent, so it goes on the bottom. Alright, now I need a common denominator. Well, I've got 6/5 of these fellas over here. I've only got 1/5 of them over here. So I need 5/5 more of them over here, so that when I add up these 2 powers, I get 6/5 and it matches. Well, 5/5 is just 1, so I'm just putting an entire one of those on the top. Now I'm going to distribute and eventually just add those 2 together. So if I distribute here, I'm going to get 24x to the 6th plus 6x all over that stuff on the bottom. And then here I'm going to get negative 12x to the 6th plus 20x to the 4th all over that stuff on the bottom. And eventually, now my denominators are the same, so I can combine things here. And I'll have 12x to the 6th, I'll have 20x to the 4th, and I'll have 6x, and then, rewrite the bottom. To the 6/5, and that's it. So it's just the 6/5. And that's what would have been up here too. So this would be there, this would be there, and then common and Alright, going on to number 6. Again, I've got a product rule and a chain rule situation here. So I don't have to rewrite it. It's already in the product rule format for me. So I'm doing the second thing times the derivative of the first thing. So 1/2. Leave the inside alone. Reduce the power by 1. Multiply by the derivative of the inside. kind of running out of room here, so I'm going to do the next one down here. So this was my 2 and my D1, and I'm going to do my 1 and my D2 down here. So the first thing is that to the 1/2, and then D2 would be the derivative of this second piece, so I need chain rule. So bring down the -5, leave the inside alone, reduce the power by 1, and multiply by the derivative of the inside. So I've got negative exponents, I've got 2 terms, so I'm going to start moving stuff around here. So for this first term, negative exponent, both go on the bottom. That's a 1/2. And then I would just look at 1/2 times -20 x to the 4th and say, okay, that's -10 x to the 4th. Plus, kind of do the same process over here. This shouldn't be a 4, this should be a -6. Sorry about that, because we're reducing the power by 1. So then I've got on top positive 45x squared, negative 4x to the 5th plus 5 to the 1/2. On the bottom, I've got this negative 3x to the 3rd plus 4 to the 6th. So common denominator time. So I have 6 of these guys over here, 5 of these over there. So I need to put another one of these over here, which will give me 6 of them on the bottom. If I put 1 on the bottom, I've got to be fair and put 1 on the top also. I have this thing in existence over here, and I don't have it in existence over there, so I need to put it there. But if I put it on the bottom, I've got to put it on the top too. And the nice thing, and this should always happen, is when you do this, these 2 numbers should add up to 1, and they do this time. So I'm in good shape there. So I'm going to have 1 of those on top. So if I clean this up in my next step, I'm not even going to distribute yet. I'm just going to kind of rewrite what we just did there. Now I'll have negative 3x to the 3rd plus 4 to the 6th. And then this to the 1/2 was always there. Plus, and then over here, 45x squared. And now I've got negative 4x to the 5th plus 5 just to the 1st. Another 1/2 plus 1/2. And my denominator here is now the same as the other denominator. So I'm going to distribute and combine. So this right here, if I distribute, would give me 30x to the 7th minus 40x to the 4th. This right here would give me negative 180x to the 7th plus 225x squared. So if I combine everything on top, 30 and a negative 180 is negative 150x to the 7th. Negative 40x to the 4th and the 225x squared don't have like terms. And then the denominator stays the same. And there we go. So we got 1 term, we added up our common denominator, and we're done. All right, that's a tough one. A lot of chances to make mistakes, so you're just being as careful as you can. On to number 7. So the biggest thing in number 7 to understand is that that squared does not apply to the cosine. That is not cosine squared, or that's not cosine of the whole chunk squared. It's the cosine of this thing squared. So the cosine is your big guy, the squared is your middle, and the inside is your little. So take the derivative of the big guy first. The derivative of cosine is sine. You leave the little guy alone. And then I move on to the middle. So the next level is the squared. So the derivative of the squared is you bring it down, you reduce the power by 1, and leave the inside alone. And then finally I get to the little, so the derivative of negative 4x squared minus 5 is negative 8x. And you could have actually just left your answer like this. Some people multiplied through some of it, some people multiplied through all of it. So I think the simplest thing to do is probably just combine those and leave this like it is. In general, you want to be factoring things into parentheses, not multiplying things out of parentheses. And just rewriting it, and there's your answer. Number 8, the rule for tangent inverse is 1 over 1 plus whatever. So here we're going 1 over 1 plus x to the 4th. I'm sorry, the rule is 1 plus 1 over whatever squared. So we're going 1 over 1 plus x to the 4th squared. But then you got to multiply by the derivative of the little guy, which in this case will give you the 4x to the 3rd. And then that 4x to the 3rd ends up on top. So one mistake I saw a lot of was people forgot the 4x to the 3rd. Another mistake I saw a lot of was making this x to the 6th. Well, if it's a power to a power, you multiply. So it would be x to the 8th. And you don't even really have to simplify it. So that's a case where if you try to oversimplify, you might kind of simplify yourself into a mistake. And you'd been better off just leaving it like this. But this would be your answer. And if you had x to the 4th squared here, that works too. Number 9, so what people missed here, the most common mistake, was not realizing that this was product rule. So this is a function of x times a function of x. So we need to be doing product rule. So the second thing times the derivative of the first thing. Well, now I need chain rule. So the derivative of e to the x to the 5th is e to the x to the 5th times 5x to the 4th. Plus the first thing times the derivative of the second thing. Well, for the derivative of the second thing, I need chain rule also. So I'm bringing down the 2, leaving the 5x to the 3rd plus 3. Now it's to the first, and then times the derivative of the inside, so times 15x squared. And then I've got these two terms. So I've got a term over here, I've got a term over here. And I want to simplify, which means I want to reverse distribute or pull out what I can. So I've got this e to the x to the 5th in both terms, so I'm going to write that out in front. I've also got a 5x to the 3rd plus 3, one of them there and one of them there. So I'm going to pull one of those out, which leaves me with one here. This is not gone because it's in front. This is not gone because it's in front. This is not gone because it's in front. And then what's left in this term is 5x to the 3rd plus 3 times 5x to the 4th. And what's left in this term is 30x squared if I multiply those two things together. So we're almost there. The only thing I would ask you to simplify here is this stuff on the inside. So if I multiply these two together, I get 25x to the 7th. If I distribute this part, I'll get 15x to the 4th. And then this 30x squared is still just chilling over there. And that's a perfectly acceptable answer. You could actually take like a 5x squared out of all of that, but you are not required to do so. And then last but not least, number 10. Again, the most common mistake was not realizing that there's product rule. And some people saw one of the product rules, but not two. There's actually a product rule there and another one there. Alright, so if I take the derivative of 5x squared, it's just 10x. Plus, so now the second thing times the derivative of the first thing plus the first thing times the derivative of the second thing. And the derivative of y is 1. I took the derivative of a y, so I multiplied by dy dx. Same thing over here. 2d1 plus 1d2. So the second thing times the derivative of the first thing plus the first thing times the derivative of the second thing. Well, the derivative of y squared is 2y, but you took the derivative of a y, so multiply by dy dx. Now, I'm going to move all of the things that have dy dx in them to one side. Well, that's just these two. And everything that doesn't, I'm going to move to the other side. So I'm going to bring this guy over here. At the same time, I'm going to move these two over there. Just remember when you cross the equal sign, the signs change. So now this 5x times dy dx is still here. This will now become negative. I'm also going to rewrite it as 8x to the third y. Just multiplying the 4 and 2 together. These two stayed over here, so 12x squared y. No, that's just that 1. Sorry, there's only 1 there. And then this 10x moves over, so now it's negative, and the 5y moves over, so now it's negative. Now you factor out a dy dx, which should leave you with 5x minus 8x to the third y. All this stuff over here is still there. And then you divide by the 5x minus 8x to the third y. These cancel out, and that is your answer. Alright, so hopefully that helps. If I can help you more, please come see me and ask.